Today I'm going to talk about edge slice re-rendering with Outsmartly. So let's start with describing a little bit of the background. A big chunk of the JavaScript ecosystem has moved to static site generation, where they build the pages ahead of time during some sort of build process on some sort of server or locally on your dev machine, all ahead of time, and then ship just static files to their CDN, right? And the reason why a lot of people have moved to this is because of the performance issues related to server-side rendering or client-side rendering. You can't have CDN caching. You can't. There's a whole bunch of issues that are. I'm not going to go into them, but well talked about in the Jamstack world. The problem is that many of these sites switch to do a ton of work and switch to static site generation, only to remember, oh yeah, you know what, actually we do still need some dynamic content, right? We still need to be able to do dynamic pricing. We need to do dynamic inventory. We need to be able to do personalization or localization or A/B testing. All sorts of different things that people might want to do that technically is dynamic content. So what have people been doing? Well, almost unanimously what people have been doing is using some client-side JavaScript to fill in those blanks. Right? So they do static site generation, but then they have client-side JavaScript for the dynamic portions of that. But the problem is, in practice, many people will find that the client-side JavaScript ends up actually reducing the benefit of static site generation. And in some cases, actually makes it even worse than if you had just done server-side rendering to begin with instead of static site generation, which is really unfortunate because static site generation is a good thing, right? And the reason behind why it's slower is complicated, but the gist of it is that JavaScript on mobile in particular, especially these low-powered devices like a Moto G4, it's too slow. It's slow to download, slow to parse, slow to compile, slow to run. It just slows things down. And it makes it even worse if you've got some sort of like third-party JavaScript library that you have to download because you've got SSL and DNS and all sorts of other additional things. So, but why do we care about performance? Why is performance important? Well, performance is important for lots of reasons. One reason in particular is that Google announced that they're going to use page performance and page experience as part of your ranking factor for your search engine, for the search engine, right? So if you have two identical websites in every way and one is slower, the one that's slower will be ranked lower than the one that was faster. So that's really important. So search engines are going to increasingly use that. Now, the probably more relevant issue is that conversion and revenue are directly tied to performance. There's lots of studies that show it. Google in particular has a really great study that shows it breaks down, the faster your site is, the more your conversions are, the more revenue you make, et cetera, et cetera. So how can we keep the performance of static site generation but still have dynamic content, right? I'm talking about the problem. Is it even possible? Can you do it? And that's where Outsmartly comes in with our new technology. So absolutely, it is possible. And that's with edge slice re-rendering. So who am I? I'm Ray Phelps, and I'm one of the co-founders of Outsmartly. If you want to, you can follow me on Twitter at _JPhelps. So I think it might be helpful to use a like kind of case study sort of thing to kind of frame the problem further. So let's frame it with, we did a proof of concept with ButcherBox, which is this company that does a subscription service meat. So you sign up and they'll send meat directly to your door instead of needing to go to the store to get it. So this is what their website looked like at the time of when we were doing the proof of concept. It's constantly changing, so it might not look like this right now. And what are they built on? Well, they're built on Gatsby, Contentful, and Netlify. Those are the primary three big technologies that they're using. What is it when they came to us? They had a couple things in particular they wanted to work. So they switched to Gatsby, but they were finding that their A/B testing and their personalization was lacking in performance, that it was significantly decreasing their page speed. So what can they do to fix that? Well, so what we did on a proof of concept was this top banner right here. We thought, well, what if we could A/B test this banner? Like you want to do a different image, you want to change the title, change the call to action, maybe the color, maybe the text on it, various things you might want to do to A/B test it. So if this is the A variant, this might be the B variant where you're showing salmon and sirloin instead, and you have a different image, right? So they're using Gatsby and they're using Contentful. What would be an ideal model for integrating that, right? It's React, but they have React developers doing these things. So what would be ideal? Well, if you go into the code for this, you're going to see code that looks very similar to this, right? You've got a hero component, you're passing in the headline, the call to action information, and the background image. Now, this might have come from Contentful. In their case, it did come from Contentful. But in your app, it might come from some other CMS. It might be hard-coded, whatever it is. Those are the props that are being passed in. If we drill into the hero component itself, it's a pretty standard, pretty typical component, right? We've got the headline, call to action, text color, background being passed in. In here, we see the text color. If it's dark, then it's using a different theme, hero dark, and if it's not, then it uses hero light. And then we can see that we've got the background image URLs being used in the source. We're seeing the call to action, et cetera, et cetera. All pretty probably straightforward stuff that you're familiar with. So if we look at that code, the mental model that we kind of wanted to come up with was that what if we were able to re-render only that component and pass in different props, like for the background, what if we were able to pass in a different background object? So we have a different background image and alt and all that other stuff, and re-render just that minimum amount. We get the background, we take the existing props and we spread those in, and then we take the new background that we want to use. That's the kind of mental model that we wanted to. Now, keep in mind, that wasn't real code, right? It's not possible to write code like that and actually have it work just like that. But we want that mental model of overriding props with the performance of static site generation. And with that, I mean, you could just do server-side rendering, right, and give different props, but then you've removed static site generation. You could come up with some sort of technique where you're able to re-render the entire component, truly re-render it, but then you're re-rendering an entire component. What if that component is high up in the tree? You'd have to re-render the entire tree below that, and it might be very expensive. You're re-rendering things that you didn't change. And that's kind of the problem with server-side rendering, is death by 1,000 cuts. You've just got so much you're doing. Even if you're just changing one little tiny thing, re-rendering the whole thing is just not efficient. So if we go back to that component, you might notice some interesting things about this. So we've got the background image URL and the background in alt there. If I change the background, let's say I just changed that background image URL, what would I actually, if you conceptually just like think about this from a human's perspective, what is it that I actually am changing? If I just passed in a new background, literally the only thing I'm changing is the source attribute on that image tag, right? I'm not changing the class name on some other thing. I'm not changing the link. I don't need to recompute the text color, all that other stuff. I'm just changing the source. So in essence, we want to re-render a tiny slice of the component, a tiny slice of your application. So is this possible? Well, we love compilers. I'm a big compiler nut. I enjoy it a lot. And there's something called static analysis, where essentially ahead of time, we're able to analyze your code. We walk in and analyze how your code is being used. And then we can do something called program slicing, where we kind of slice your code up into segments and data flow. We do data flow analysis and control flow analysis. Essentially, we just figure out how, when data flows through your application and your components in particular, what does it do? How does it impact things? So if we go back to that component again, we can see that this is the sort of thing that we would analyze. We would see, okay, we've got heading, call to action, text color, background. We've got the theme is equal to the ternary, and we flow through the theme into the class name, right? So if we were to do static analysis and extract all that out, we can see that, look at that, we've got code slices. We have a minimum amount. If you change text color, look at all we need to do. We need to just recompute that ternary, and we need to recompute that class name, that hero, and uses the theme class name, right? That's the minimum amount we would have to do. If we just change the background image, we don't have to rerun any JavaScript really. We just need to change the background image on that image tag, right? The source attribute. And that's code slicing in essence. But doing that manually obviously is untenable. So that's where the compiler comes in the static analysis. The code slicing extraction happens automatically ahead of time. The compiler extracts out that and along with analysis information so that it knows if you change a particular prop, what is the minimum amount of JavaScript that I would have to run to make that change, and then where on the page can I actually apply that change? So that way I don't have to recompute the entire application. I don't even have to recompute the entire component, just the minimum amount. Awesome. So now that we have a technique for doing that, how do I actually get the props, right? I said the mental model is overriding props. How do we get the props to the system to override them? Well, we came up with something we call overrides, not particularly original name, but this is what an override looks like a very simple hello world sort of override for that component. At the top we can see that we're saying we're targeting that particular component. Now this is like a selector. You can think of it kind of like a CSS selector, but we're targeting that particular component. And then we've got a lifecycle function, get override props, where we're expected to return we only need to return the props that we want to override. We don't need to return all props, just the props we want to override. And in this simple example, we're just having a hard-coded background. We say, here's our new background image, and we return it. And so you do not have to return all the props, just the props you want to override. And that's what's key so that the system can figure out behind the scenes, what's the minimum amount of work that needs to be done. So that's a simple override. If we were to apply that override conceptually to that butcher box component in production, it would do exactly what we thought. We have the original image, and now we have the new image, right? Original image, new image, original image, new image, right? Oh, sorry. There we go. Now I'm switching between it. So what about that? I've highlighted the headline and the call to action. What if I wanted to modify that? Well, now we're starting to override more than one prop, and we don't really want to hard code these things. We want to allow like a marketer or a developer who's doing these A/B tests to modify these things on the fly and create new tests without having to go and write code and change code, right? Well, ButcherBox and a lot of these static site generation websites use a CMS, and in this case they're using Contentful. So if we were to create a A/B test data model in Contentful, we can see that we've got 3 variations here. Now we've got the free strips and bacon and lobster variation, bacon for life, free salmon and sirloin, 3 variations where if we drill into those, it'll have the props for the headline, the color, etc., etc. Swinging back over to our override, now we can see that we've got a little helper that it doesn't matter how it actually works under the hood, but essentially fetch from Contentful is just this little helper that we've written to allow you to do an API call to Contentful. And we're going to do stale while we validate. And that's really important so that basically we will asynchronously check, we will basically asynchronously revalidate, is there a new version? And if there is, we need to cache that new version. That way, once there is a version in the cache, any subsequent person requesting it doesn't have to wait. Stale while validate's really great. And we take those variations that we fetched from Contentful, and then we do an assign uniform, a uniform assignment. So we have a key where we say, here's our deterministic hash sort of thing. So we pick a particular one. And then here are our new props. We're saying we want to override the headline, we want to override the text color, and the background. There we go. That's our override. Swing back over to the website again. There was the original, and there is the variation. You can see that get free salmon and sirloin is the new version. The old one was free strips, bacon, and lobster. So we were able to do A/B testing using edge slice re-rendering and the overrides. So we've got those two pieces, right? We've got the override and we've got the code slices. There's still a missing piece you might have noticed it. So where does all this run, right? Like we're saying we don't want client-side JavaScript. So putting it on the client side is not a solution, right? Server-side rendering, well, if we're doing static site generation, then we're not doing server-side rendering, right? That doesn't make any sense. And we don't want to do that because we'd have to go all the way back to the origin and we can't cache the HTML at the edge. So that's exactly where we're going to do it then. We're going to do it at the edge, at the CDN layer, so really close to the end user. So we're able to cache the HTML and apply the minimum amount of JavaScript needed to make a change on top of that HTML. And that is exactly edge slice re-rendering. So, or ESR for short is what we call it. So in ESR, just to be clear, is not something that you use just by itself. It doesn't replace static site generation. You use it in tandem, in combination. And if you wanted to, you actually could use server-side rendering and then just cache at the CDN, the server side. If you wanted to use server-side rendering as kind of an incremental static site regeneration sort of way, like if you're using Remix is a new framework by Michael Jackson and Ryan Florence that is really all about that, where it's saying, I don't necessarily want to use static site generation, but I want to have the mental model of it sort of, where you just have good cache headers at the CDN, and you effectively create ad hoc static site generation, right? So I've been really pressing that performance is a big deal. How fast did that page actually get downloaded? Like how fast can those things be applied on top of that? And the answer on this is literally the real timeline that came from this is 36 milliseconds to do all of it, to get the page. You've got the page at the CDN, the HTML page, and the edge slice re-rendering runs to generate the minimum amount of JavaScript to change that headline and change that text color and change that background image. It applies those changes to the HTML while it's streaming to the browser. And then there you go, and you're ready. So let's take a look at a video, a timeline, showing the performance difference of possible ways you could do this. We've got the baseline on the left, which is just static site generation cached at the CDN without doing any dynamic changes whatsoever. Still using Gatsby, of course. We've got static site generation, but now using ESR with Outsmartly, where we're able to apply that A/B test. We've got another one using server-side rendering, so this has to go all the way to your origin, right? And this doesn't make any external API calls. If you needed to do API calls external, that could actually slow things down even further. But this was not doing that. And then the last one is the most common thing. We've got static site generation with client-side JavaScript. And this is using a really, really, really popular A/B testing tool service. So let's see how they perform. Okay, so that actually goes pretty quick except for the last one. So I'm going to restart that and do it a little slower so I can kind of talk through it. So on the left, we got the baseline, right? And we'll see pretty quickly the baseline and the ESR version come in at almost exactly the same time, followed just a little longer over by server-side rendering. Server-side rendering, the initial version, the HTML comes in, but the image takes a lot longer to come in, right? And I'll explain why in a second. And then on the far right, you've got the client-side JavaScript. Now you'll notice we're still waiting. We've got the text, thankfully, but we're still waiting on that image. It has not yet. Oh, there we go, finally. And so I'll kind of briefly talk about why this is the performance characteristic. So why server-side rendering? Well, it has to go back to the origin. You can't cache it at the CDN, right? Unless you're running it at the CDN, which does help. The edge is getting better and better and better, and so some applications can run server-side rendering at the edge, just to be clear. But this is not doing that. But the big thing that really killed it, if you were eagle-eyed, the text comes in fairly quickly. The big thing that kills it is that image, and there's a bunch of reasons why. But one of the reasons is that you're getting contention if you looked at the timeline of requests that are coming through, you'd see that the image is actually competing against other resources. Whereas with Outsmartly is actually able to select the right image at the edge and actually push it. It uses HTTP push to preload that image so that there's less contention with other resources like JavaScript and fonts and all sorts of other things. And then part of that, the server-side rendering time is just generating the page itself, right, on the server, death by 1,000 cuts. Then the worst one is on the far right, the client-side JavaScript solution. And this one is a couple different things. So it's using an anti-flicker snippet, which is almost universal what people do, because you don't want it to flicker back and forth between the old and the new version. And so what happens is the page gets downloaded, but it's completely blank until the A/B testing tool is able to do the A/B testing thing. So it fetches its variations client-side, decides what the minimum amount of work is to do it client-side, and then applies those changes client-side. But if you're doing all that client-side, it's got to download the JavaScript, parse the JavaScript, run the JavaScript, make third-party calls, and then all the while, all that stuff is having that contention that I was talking about again, where where if you have a JavaScript bundle that's downloading interactivity stuff from Gatsby and Next and all this other stuff, it's competing. Even images below the page might be competing for this sort of thing, even though this is above the fold. So it's a whole bunch of things that kind of work against you. And 7.1 seconds on this is actually what we've seen fairly good. Like we've seen much, 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 much worse when you're doing client-side A/B testing. So it's really cool that you can have your cake and eat it too with edge slice re-rendering. So the target that, just to be clear, this is on a Motorola G4 device using a 4G network. And the kind of target ballpark that people at Google and a couple other companies suggest is somewhere around 2 seconds or lower is what you kind of like would be a really great fast experience for this device. On your desktop, it would download much quicker, of course, because you've got a great connection, great fast computer, etc., etc. So the clear winner in this case is obviously the ESR with static site generation. Real quick, I wanted to talk about personalization. There's a whole bunch of things you can do with ESR, but in the case of personalization, here's a simple example on ButcherBox that we did on the proof of concept. They've got a blog where they show their recipes. And it's really great. They're great recipes, but it's also lead generation, right? That's why they're doing it, is people will come see a great recipe and they'll see, oh, there's a service where I can actually buy the meat for this recipe and then have us, have my meat delivered every month, every week, whatever it is. So what we did is instead of just showing a generic thing, like when they, in this case, like if you land on a top sirloin recipe and then you go to the butcherbox.com website, shouldn't we show you things about top sirloin instead of showing you lobster, right? Like, aren't you more likely to convert if you're actually seeing things that are relative to what you just saw? And that's exactly what we did, is if you land on this recipe page, we're able to keep track that, oh, okay, they're probably interested in top sirloin. So when they go to butcherbox.com, we can say, hey, well, just so you know, we're running a free New York strip steak promotion right now. And you can see the really tasty looking steaks, making me hungry actually. But if this was, like you can see at the very top, they were also running a free lobster promotion, right? You can see at the very top, there's a banner. If we had instead showed that promotion here with the image, they're far less likely to have known that promotion exists and far less likely to have signed up. So that is one example. And so let's say that they come in on another recipe for bacon, right? The exact same thing wants to happen. If you go to the homepage, now let's say you're running a promotion for free bacon for life, which they're not doing, but that's just an example that we came up with. You should show that, right? So that is edge slice re-rendering, or ESR. And it's really designed to not really replace any of the existing technologies you're using, but by and large to augment them. Like if you're using Segment, or you're using Clearbit, or you're using Netlify, Vercel, even if you're using Optimizely or Google Optimize, they actually can work well with this. This just does those, you can use those things for your analytics or for your selection, your variation selection, but take advantage of the performance benefits of Outsmartly. So Outsmartly is enterprise ready today. We're in production with a number of commerce sites. And right now we have a public developer access program that you can sign up for, and we're gradually adding people based on their use case, and we're gathering feedback from them and piloting it that way. If you want to take a look at an example of what does like an entire app look like with overrides and these sorts of things, we did create a kind of an open source demo app that you can take a look at that uses Gatsby and Outsmartly. There's also a link there where you can actually view it live. And if you want to run Lighthouse, or you want to run web page tests or any of that stuff on it, just see what the performance characteristics, because it does. It's a demo that does it's a fake Task Mallard website that does, it's like TaskRabbit clone that does personalization and A/B testing. So that's Legislation Rendering. If you want, you can follow me on Twitter at _JPhelps. Thank you very much.